So we'll start building the architecture that is essential to understand. Okay. I just wanted to follow up with the construct of the process. Okay. For any system you are fundamentally working, there will be some relational environment and it will be having its own object oriented requirements. Okay. I don't say like every system should definitely contain object oriented environment. But in order to store your data, if you think that you want to store your data, then definitely you should have some relational environment. Am I correct? We have been working with relational environment all these days. We don't have any fundamental confusions behind this. Now, suppose say like you're working in any particular project where data management has to be done. I'm making my points very clear. Where data management has to be done, the first level of the architecture that is fundamentally created, is a relational architecture. Once we plan everything in relational environment, on that particular environment, we start planning the remaining number of constructs according to the requirement that fundamentally arises. So just come along with me to understand, okay? There is some criteria of the relational system that is already existing. Let us say with a criteria of the cardinalities that are happening like this, where I'm having one course table where I will register all my courses. Then a student will join the course. So we are having one student table where all the student details are collected along with the course in which the student has joined. And we are having the student mentors in the sense the faculties. Okay. So we are having one table that is absolutely going to have the list of all the faculties who are part of that particular institution. And one faculty can always act as a mentor to multiple number of students. So the student ID along with the faculty ID integrated together is definitely becoming one composite state of the data. So now don't you think that here we are having multiple number of primary keys and foreign keys, because of which no doubt we are in high level normalization very perfectly. Upon normalization principles, everything is going properly. We don't have any complaints on that. But one thing what we want to just understand is, if I want the details of the courses, the students and the faculties and the mentors, then don't you think that I have to join all these four tables compulsorily? Now, joining these four tables is not a problem for us. But every join we execute in a real-time database is going to kill the performance of the system depending on the size of the data. Do you agree with me? So we are not against to the relational database management system services, because for years together, these relational database management systems have been developed. Nobody can deny that. So we are not against to these constructs. But the only thing is, these relational database management systems, whenever they are implemented, technically, they can give you services with highest amount of normalization principles, where normalization principles will definitely provide you very highly consistent data with the least redundancy. All those advantages are there. But the more we normalize, the more the number of tables are created. Because of that, we need to execute more number of joins to get implemented when we want to return the information that is demanded by that particular business environment. And we also know that a fundamental relational database management system will try to do all these operations where a pre-built RDBMS application will be working effectively with all the required CRUD operations. Means you have hundreds of tables like this or thousands of tables like this, that doesn't matter. But finally, the concept is, can we make a security state of the data along with the performance and speed? So we are building one small architecture, man. You need to just understand this, okay? I'll pick up a diagram with the entire flow as we go down, but I'm not drawing the diagram from the scratch, okay? It will take time for us. Therefore, I just want to go with the diagram that I'll show you. But once you start catching up my basic process, you'll start understanding, okay? Now, let us assume that we are already having a relational database management system that is working effectively, man. And by the requirement of my client, whenever I listen, I came to one conclusion that the situation what the client is demanding is more better implemented by a scenario of object reference architecture. Means what? Every student can have a student in charge, and these student in charges and students are in two different tables. Let us say we want the data of the students and their in charges with their students very heavily, effectively, without having any performance issues. So for that purpose, what I'm doing is we are building one table called as student in charges. Yesterday I was just explaining this table. But watch, this table is a very special kind of table. This table is having one of the column which is a relational column. The other column is a column that is referencing to the student. It's a column that is referencing to the student. Where we know very well that at any point of time, technically, data type never contains any data, only its instance contains the data. Only its instance will contains the data. That we know very well. So on that context, you just watch this criterial diagram, okay? You just go on working along with me, you'll understand, don't worry. In this particular diagram, there is some area where we are creating one student in charges table, having one of the column with in charge name and student in charge column, which is acting as a reference to the student type. Okay, which is acting like with a reference to the student type. So this second column of this table is actually in association to this data type. It's actually in association to that particular data type. On one data type, we can have only one object table or any number of object tables. Any number of object tables. Currently, we are speaking about only one single object table, that is nothing but the MCA student, where this MCA student is containing collection of object records, where we know that every object record internally contains an object ID that is generated by the Oracle's internal architecture. Now, in practicality, if you are thinking, there is one relational system. Actually, there is one relational system where all this data is already collected. All this data is already collected in the business under one relational system. And this particular data with all those relations and the normalized principles is getting managed in one centralized server, which is fundamentally organizing the data in the principles of RDBMS. Am I clear with you? Now on this RDBMS implementation, the relational clients are continuously working and they are executing all the CRUD operations that are expected. So we don't have any complaint. Our relational system is very perfectly working. It's 100% effectively working. We don't have any complaints on this. But due to technological inventions and the kind of interfaces that are changing, we want to access the database from remote locations with the highest speed, consistency. In the public networks, it should be secured by its nature. The actual location to the data and its objects should not be revealed in the public networks. These are all kind of requirements. Once they are arising, the client came up with all these issues in front of me, let us say, then no doubt we can give the alternate architectures using any technologies, man. There are so many number of technologies in the world, but we being SQL developers, we have to understand that in Oracle's SQL also we have definitely certain number of features that can make you think in object oriented standards, and we can make the relational architecture objects get migrated with their data into object architectures, generating with object IDs and putting references that are essential to make the application more secure and more faster. So keeping that in the mind, I am creating one student type, which we already created in the previous classes. Okay, we have already created the student type in the previous classes. A type never contains any data, so we are creating an object table by name MCA student, and then we are trying to collect the data. Normally, we insert the data in the classroom like environments, but in real time, you should understand all this student data is already there in the RDBMS environment or not. So we don't need to reinsert once again. So I'm just executing one on the fly. Okay, I'm just executing an on the fly statement by saying insert into MCA student, select star from the student table in RDBMS where the course ID is equal to MCA. All the students from my relational table, they are selected who are belonging to MCA, and they are immediately inserted into the MCA student, which is doing on the fly insert. Am I correct? Now, I want some answers from you. These all students this side, they are in which particular state? Relational state. Okay, they are in relational state. These students, because of this on the fly insert, they are now getting migrated. They are now getting migrated into object table. Am I correct? Now, when these students are getting migrated into this object table, automatically by the construct of the object oriented implementation, these records which were actually relational by nature, they are now becoming object records getting generated with their particular object IDs. So just because these records have been transferred into an object table, their state of entire behavioral standards have changed. These records became object records and they are having their own object IDs now. Am I clear with you? Now these object IDs we want to access as references everywhere. So what is my advantage if I'm struggling like this? Just try to understand the architecture. By the time I complete my executions, it will be very clear to you. So keeping all this in mind, I'm creating one table called as student in charges. where within the student in charges, what we are actually trying to create, one column is in charge name with varchar 2 and the other is student in charge, which is a reference to the student, type. So now let us just go and create this table first of all. Okay, so just was the structure of this table, man. So I just wanted to check very properly. This column is a relational column storing the data in varchar 2 format. Okay, hence this column can always react this column can always respond to the relational DML style. But the second column, if you are watching here, watch this column. This column is a reference to the student data type, which is user defined type created by the SQL developer. Okay, which is definitely expected to store the data as object IDs of the object records stored in object tables elsewhere in the actual application. Are you getting me? This column cannot respond to the general relational DML. So here to insert the data, we need an insert statement. But here we need object ID. To get the object ID, we need a select statement. So technically, we have to cross check very carefully the way we can implement this particular insert now. So I just want absolute concentration from you to catch up through the scenario, man. Okay. So first let us create this object reference table. Now, if you are saying describe MCA student, your MCA student is definitely depending upon the structure that is inherited from the student. Am I correct? Am I correct? Now, you just watch carefully. I'm saying describe student in charges. When I'm saying describe student in charges, it's just showing me two columns where the second column is clearly saying that it is a reference of the student. Okay, it's very clear saying it's a reference of the student. Means this column is definitely operating to the structure of this. But on that particular structure, we are having object tables that have been created. Therefore, you just watch carefully. We are saying set describe depth of 2. When I'm saying set describe depth of 2 and I'm describing, is a very clear evidence that the second column is inheriting definitely the structure that is associated to that location. Am I clear? So the second column is very clearly saying that it will store the object IDs that are generated by the object records in the object tables. Okay, all this is looking fine, but finally how to insert the data? So your insert is a very special kind of case in these kind of tables, where technically to insert the data into these object reference tables, wherever the reference columns are there, we will go with on the fly inserts. Because using only the ref function, you can get the object IDs, and technically your ref function can be used only in select statement, but select statement cannot directly insert the data. So what we are doing is we are calling the insert statement on the object reference table by writing a select statement upon the criteria and composition of the object table by adjusting the criteria of the in charge name as a literal here. Now, I want you to catch step by step what I'm trying to do now, okay? So that you can just make up yourself convenient. So final goal is we want to insert the data into this table, okay? So now, I want definitely a few answers from you. Suppose I'm executing this select statement. Can you just tell me this select statement actually returns what? Come on, this select statement actually returns what? Can you just tell me? Any error? Any error? Definitely not. Okay. The select statement will produce this Subramanyam Sharma with the alias of in charge name for the student called as Seshu, that is found in the object table called as MCA student. So the Subramanyam Sharma is now acting as a literal. It's just acting like a literal. Am I correct? So just slowly let us start moving on now. Okay. So now you just watch carefully. This output that is coming is a varchar 2 type of output. Can I say that? Now, this particular data, whatever we are presenting through the in charge name column on this select statement, I think it is looking suitable to the criteria of the column called as this. Am I correct? Now, I just want you to answer me once again. Okay. I'm going with one more statement, man. Okay. The next statement, what I'm taking is watch. I am saying ref of MCA, and then I'm just giving a name. You just watch. That is nothing but student in charge. Okay. I'm just giving the criteria of the alias called student in charge. Now this is ref function. Ref function returns what? It returns the object ID. Okay, object ID of that corresponding object record. So I'm executing this select statement once again. So this is the object ID of Mr. Seshu. Do you agree with me? So these two select statements are promising me that they can get me the literal as a varchar2 type and the object ID. Now finally, I just wanted to concentrate. I am saying select Subramanyam Sharma with an alias of in charge name, comma, ref of MCA with the student in charge as an alias. I'm putting this where clause as it is, along with the from statement. Okay. Now this select statement is operating to get two columns in projection. Am I correct? So the first column is in charge name, which is varchar2. The second column is object ID. Now seriously, if you're concentrating, I think this is fundamentally looking suitable to this. Am I correct? And this is fundamentally looking suitable to this. The structure that is returned by the select statement, is it not looking equivalent to the structure what my table called as student in charges is expecting? So it's always your thought process when, see, from the scratch, from my initial level classes, if you have seriously been coming up, then I don't think we are doing anything too complicated here. But you just don't pack your basics properly and suddenly you see these kind of constructs, you get confused. But I think with so many different number of classes, we have been making ourselves get ready to this particular level, putting the foundation very properly. Do you agree with me? Now it's very simple, man. I think we have already discussed on the fly inserts. Yes or no? Now these on the fly inserts can always take the data from the select statements and they can return the data to the insert statement, and insert statement can insert the data into the target table. So now the only thing what I'm doing, you just watch now. The only thing what I'm doing now is I'm just calling the insert statement on this. Okay. By saying into the table name is student in charges. And then the first column to which we want to insert the data is in charge name, which is a varchar2, comma. The next column is student in charge, which is basically nothing but the object reference column. So first the select statement will get executed, returning the data into the runtime SGA. From there, the data will be picked up automatically by this insert statement, and the insert statement will be inserting the data. So I just want to keep one point very, very clear. When you create any object reference tables, the only way we can insert the data into the object reference tables is by building one on the fly insert statement by calling the ref function within the select statement of that insert statement. So whatever the select statement is returning, that data started entering into my table called as student in charges. Whatever I discussed with you till now is nothing but this whole architecture that's happening now. That's the whole criteria of the architecture that was happening with whatever I discussed. So your insert statement is getting built with your select statement, where your select statement is contacting the object table called as MCA student, and it is returning the corresponding object ID to the ref column, and that data is now getting into my literal of Subramaniam Sharma's in charge name and the corresponding object ID into the student in charge column. Clear? Clear. Now, even though this architecture is looking too complicated for us, but I think with all that experience we had from so many number of days, I think we can definitely understand this architecture now. See, I want to make one point very clear, man. It is your greatness you have been sitting for the sessions for so many number of days. If you are also a person like everybody in the market, I want to learn the whole database in 20 days, 25 days, 30 days. Now, I don't think I can take the liberty of discussing this kind of architecture with you. So every day you are part of the session is now adding up something very wonderful to the next level. That's just because you have been spending your time, that investment, what you have done on your time is giving you the experience now. Am I clear with you? Now, don't you think that looking into this, we can handle any kind of relational architecture to be converted into an object-oriented implementation? So, are you understanding in real time how the traditional projects that have been developed long back in RDBMS functionalities, they can now slowly get converted into object-oriented standardizations? But it just needs a thought process of the transformation, what we have to do. That's one thing. Second thing is really more wonderful. What Oracle is doing internally. Here we took the data from the object table and immediately we transferred the data into the student reference table. In between, did we do any kind of other transformations? No. Now this is your original object ID of Mr. Seshu. Do you agree with me? It was the same object ID. It is returning at this level, and that object ID is now getting inserted into this particular table. Okay. But what is happening, you watch, I'm querying this target table on which we have inserted. Now first let me commit this, okay? After this, we are just trying to write a select statement by saying select star from student in charges. When we are executing this, no doubt the first column should give me the in charge name as Subramaniam Sharma. The second column should give me this object ID. Do you agree with me? Now let us just see what's happening. No doubt your first column is returning exactly that Subramaniam Sharma. No complaints. The second column should return the object ID and it's returning the object ID. But the beauty is you watch very carefully. When you just watch very carefully, the cross comparison of this object ID and this object ID, are they exactly looking same? Definitely not. So Oracle is having one very interesting intelligence in its architecture. When the reference function is returning the object ID, that object ID, when it is being inserted into the corresponding object reference table, it is just trying to abstract the data only to the level that is essential to the next level of the insert, hiding certain information that is not essential. Am I clear with you? I don't think we are doing any serious programming in all these cases. We are just using the facilities provided by Oracle from its architecture by using certain functions that can really do these kind of activities very effectively. So, unbelievable compositions. Now, I think we have migrated the object ID into our in charges table, Now here, one of the biggest question what the beginner will have is, so all this is looking really good, but when my student in charges table is queried, now my actual student in charge is unable to see the student's data, but is seeing the object data, then technically, don't you think that we are hiding the total student's information from getting exposed? Yes, that's really good. It's giving you security now, which is not really telling you what is the actual location and what is the actual state with which the data is existing for the reference of the student. So if any hacker or cracker is entering into my environment, if he's stealing this data and if he's running away, let us say, do I have anything like he's getting exposed with any data directly of my business? No. Is he knowing the actual location from where the data is operating? Definitely not. But finally, I think the Subramaniam Sharma, who is in charge to this student, he wants to see the information of the student. Do you agree with me? But he cannot understand student with his object ID. That is where your deref function will comes into the picture. Okay, what we have been speaking in yesterday's class, that's where your deref function comes into the picture, which takes that object ID as a argument, and it just returns you the original details of that object to the location where that object is existing. What a beautiful architecture, man. So in the next few minutes, I want you to understand how the deref is working now. Okay, and the other wonderful things what deref actually does in all these circumstances. So let us see what exactly the deref does. I am going into my select statement and I just want to get my data from student in charges table, where I want to give an alias to this as student in charge, where in charge name is equal to this Subramaniam Sharma. Okay, but I want to project the data now. When I want to project the data, if I call this student in charge column directly, watch carefully. If I call the student in charge column directly, it will give you an object ID. But I'm not interested in object ID. I want the original details of the student in the object form. Now I want one answer from you. The student called as Seshu is exactly in which table? Come on, is in which table? MCA student object table. Do you agree with me? Subramanyam Sharma as an in charge is in which table? Subramanyam Sharma as an in charge is in which table? Student in charges table. Now what we are expecting is, I want the details of Subramanyam Sharma and also the total details of the student who is controlled by Subramanyam Sharma. So I have to get the data from how many tables now? 2 tables. Now, if you want to get the data from 2 tables, technically you should execute what? Joins. Comparing the common data. Do you agree with me? Now, I want one answer from you. In between these 2 tables, if you want to really write a query, that is MCA student and the in charges, what is a common column in between these 2 tables? Come on. Object ID? No, no, no. You can't say that, because in MCA student, we don't have any object ID. I kept this column as a reference for you. Be very, very clear about that. I just kept this column as a reference. We don't have this column along with the table. These object IDs are generated at runtime, or they're already available and they are inserted by the developer. They are generated at runtime. And we don't have any object ID column on this side also. It is a reference column, but it's not an object ID column. Between these 2 tables, logically there is some common data, but physically we don't have a structure that can represent that common data. Do you agree with me? In between 2 tables, when you do not have a structure that cannot operate to the commonality of that particular data, how you can write a join condition? Because we know very well that joins depend upon the physical state of the columns, which should be recognized in the form of primary key and foreign key as values. But here we don't have anything like that. But one thing is very clear. One thing is very clear. This object ID, can I say, just catch my words, this object ID, can I say it is a migrated object ID of the object record in object table? Can I say this statement? Yes. Because it is a migrated object ID, we know very well that behind every object ID, there is some information about the object. Do you agree with me? So on that object ID, whatever kind of object data is existing, if I want to see, I can see that particular data by applying a dereference function, where dereference function is always expecting a reference as an argument. So what we are doing, you just watch, we are simply trying to say that deref of this student in charge alias dot student in charge, and I'm closing the bracket. Now this column is now containing a migrated object ID. Under the qualification of this aliased object reference table, because you're returning a migrated object ID as an argument to the deref function, the job of the deref function is to go and search the object table in which the data is existing and get that object record directly. Get that object record directly. Am I correct? So If you want to get the in charge name, we can get that in charge name from this table. Am I correct? So that is not a problem for us. That is not a problem for us, that we can just check here. But if I want the details of the student, I should go to which table? MCA student object table. But in this query, did we mention anywhere the original name of the object table? No. First thing is, we are getting the data from two tables. We are not mentioning the second table's name. That's first point. Second point is, to get the data from two tables, we should definitely write a join condition that can get the data that is joined with a consistent state. But do we have any join condition here? No. Are we using anywhere the common data columns and executing the query? No. See the beauty of Oracle now. It's automatically going to the MCA student object table, and it is getting the data through the constructor automatically. Is not this query is hiding the original physical architecture of my object tables and is able to get the data from the object table automatically by understanding the information that is existing within that object ID that has been migrated. Am I correct? Show me a technology that can really make you do this kind of operation in such a simple way, man. In such a simple way. Unbelievable. So where are joins today? We are not saying that we are against to joins, but don't you think that with all this discussion we had today, we can make an existing relational architecture get converted into an object reference architecture that can really give a wonderful environment to communicate only with references without having any physical joins. Am I correct? There are two advantages here. What are they? One, security. Two, speed and performance. The third is, without damaging the existing relational architectures, without damaging the existing relational architectures, we are promising the industry that we can build object reference architectures as an extension. So anything that is developed long back, shall we need to immediately collapse for the sake of new technology? No. That's where Oracle really looks very, very wonderful when you come into the object-oriented thinking. That was a very small piece of enhancement from yesterday, what we have been thinking, man. In tomorrow's session, what I'll do is, we will see how we can extend this object architecture with more number of object tables and make all these object tables to get into a reference architecture by using the dereferences without establishing at least one join, how we can go and get that particular piece of the data from all the object tables without knowing their physical locations. So here, anytime your relational data is changing, then definitely the object state data should change. Now that is where I think we always have in industry the job scheduling and object or any data loading concepts taking place 24/7 in the process. So whatever is happening in the relational environment that should come to me into my object means we need to have some kind of scheduler that can do the job of scalability. Are you catching the point? Now DBAs will take all that responsibility, don't worry. So if you are seriously keeping this into your mind, tomorrow we'll make a great enhancement on this architecture, man. Just let us see in the next 24 hours what is exactly waiting for us. Thank you very much. Once again with you tomorrow. Have a nice day. Take care of yourself.